Tonight, scientists are seeing lower water levels in the Great Lakes, a change from these images of homes disappearing into the water after we saw high levels just a couple of years ago.
What if the largest freshwater system on Earth is hiding far more than anyone imagined? Beneath the Great Lakes are 9,000-year-old hunting grounds, thousands of shipwrecks, ancient carvings from a lost world, and water that cannot simply be replaced if it is ruined. Some discoveries have left scientists genuinely shocked, and the deeper they look, the stranger the story becomes. A system out of control. Between 2013 and 2020, the combined water level of Lake Michigan and Lake Huron rose by 6 feet. 6 feet across two lakes of that size means trillions of additional gallons of water. Shoreline properties that had existed safely for decades were suddenly underwater. Beaches disappeared. Structures that had stood for generations flooded. Then the levels dropped again, almost as quickly as they had risen, and the damage from the retreat was different, but equally severe. The speed of these swings is what concerns hydrologists most. The models used to predict lake-level behavior were built on historical data that showed gradual seasonal changes operating on relatively predictable cycles. What has been happening in recent years does not fit those models. The lakes are rising and falling faster than the science built to understand them can track. And the consequences of each cycle, flooding on the rise and exposed toxic sediment on the fall, are severe enough to affect millions of people directly. The common assumption about a system this large is that it is stable. The data says otherwise. The Great Lakes behave more like an ocean than a reservoir, generating their own weather systems, responding to atmospheric pressure changes in ways that can shift water levels by feet within hours in a phenomenon called a siege, and responding to climate patterns that human activity is changing faster than the lake's natural buffering capacity can absorb. The system is not under control. It has never been under control. The illusion of control has simply been easier to maintain when the swings were smaller. Fossil water. All water in the Great Lakes flows in one direction, northeast through the St. Lawrence Seaway and eventually into the Atlantic Ocean. The water that leaves does not come back. Rain and snowfall replenish some of what is lost, but the math of that replenishment is startling. Less than 1% of the lake's total volume is renewed each year by precipitation. The other 99% is what scientists call fossil water. Fossil water is not a metaphor. It is a technical description of water that fell as precipitation during the last ice age more than 10,000 years ago, was captured in the basins that glaciers carved out of North America, and has been sitting there since. It has not been part of the active water cycle since civilization began. It is, in the most literal sense possible, ancient, non-renewable water. If it is used up or contaminated, it cannot be replaced on any human timescale. The geological processes that would produce a comparable water body would require another ice age. 40 million people drink this water. The 8 American states and 2 Canadian provinces bordering the Great Lakes depend on it for municipal water supplies, agricultural irrigation, industrial processes, and 100 other daily uses. Chicago gets its water from Lake Michigan. Detroit gets its water from Lake Huron. Toronto gets its water from Lake Ontario. Cleveland, Milwaukee, Gary, Buffalo, all of them drawing from the same glacial inheritance that has no replacement. The threat to that inheritance is accelerating. Warmer air temperatures mean less winter ice on the lakes. Ice cover on the Great Lakes has averaged around 50% historically. In recent years, that average has fallen below 10% in some years. Ice insulates the water surface and reduces evaporation. Without adequate ice cover, evaporation increases significantly, and that evaporated water does not return. It joins the general atmospheric moisture cycle and falls as precipitation elsewhere. The fossil water is leaving the system faster than the models had projected. The underwater Stonehenge. In 2007, archaeologist Mark Hawley was conducting a sonar survey in Grand Traverse Bay in Lake Michigan. He was looking at the lake bed at around 40 feet of depth when the sonar data showed something that required a second look. The stones in the area were not scattered in the random distribution that natural processes produce. They were arranged. Further investigation revealed a boulder among the arranged stones with a carving on it. The carving depicts an animal. The animal it most closely resembles is a mastodon, the large elephant-like creature that went extinct in North America approximately 10,000 years ago. The carving is not modern. The style and weathering are consistent with something very old. Someone carved that image on a boulder that is now sitting on the bottom of Lake Michigan. The implication takes a moment to process. For someone to have carved an image of a mastodon on a boulder at what is now the bottom of Lake Michigan, two things had to be true simultaneously. The area where the boulder sits had to be dry land, and mastodons had to be alive and visible enough to be worth depicting. Both conditions existed during the same period, the time after the glaciers retreated but before the meltwater from those glaciers had fully filled the lake basins. Around 10,000 years ago, the area now covered by Lake Michigan was in places dry land, populated by people who hunted large animals and left marks on stone. Hawley has not claimed certainty about what he found. He has said clearly that he cannot explain it away. The carving is still down there. It has not been comprehensively studied because the cost and logistical difficulty of sustained underwater archaeological work in Lake Michigan at 40 feet across a broad area is significant. It sits on the lake bed and waits. The lake that keeps the dead. There is a saying around Lake Superior: the lake never gives up her dead. Most people who hear it assume it is poetic language about the lake's power and unpredictability. It is not poetry, it is chemistry. Lake Superior is 1,200 feet deep at its maximum depth. The water at the bottom is near freezing, contains very little oxygen, and receives no sunlight. In those conditions, the bacteria responsible for decomposition cannot function. Things that sink to the bottom of Lake Superior do not decay. They stay approximately as they were when they arrived. The human toll associated with those wrecks is estimated at around 30,000 lives lost across the lake system's history of commercial navigation. The Edmund Fitzgerald is the most famous of those losses. A 729-foot freighter that was one of the largest vessels operating on the Great Lakes when it sank in November 1975, it went down in a storm on Lake Superior without sending a distress call. 29 men were aboard. None survived. The wreck was found in two pieces at 530 feet of depth. The cause of the sinking has never been definitively determined. Investigators have proposed structural failure, flooding through hatch covers, and other mechanisms, but no single explanation has been accepted as conclusive. The lake took the ship and the men and has not offered a complete answer to what happened. The storms that produce these losses have their own nickname in the lake region. November storms on the Great Lakes are called the Witch of November. The combination of cold air from Canada meeting the still warm lake water produces storm conditions that can exceed anything coastal sailors expect from ocean storms. Waves exceeding 30 feet are documented. The violence of Great Lakes storms in late autumn has been claiming ships and lives since the first boats were launched on the water. The triangle nobody mentions. The northern half of Lake Michigan has accumulated a cluster of disappearances and unsolved incidents over the past century that some researchers have begun referring to as the Michigan Triangle. The designation is not officially recognized, and the scientific community treats it with appropriate skepticism. The cases within it are, however, genuinely unresolved. In 1937, the captain of a ship called the O.M. McFarland vanished from his locked cabin while the ship was underway in the lake. In 1950, Northwest Airlines Flight 2501 was crossing Lake Michigan when it disappeared. The plane was carrying 58 people. Debris was recovered. The main fuselage and the bodies of the passengers were not. 75 years of subsequent searching, including modern sonar surveys, has not found them. A commercial aircraft carrying 58 people in a lake that has been sonar mapped in significant detail has simply not been located. The explanation that satisfies scientists most readily involves the lake's depth and the extreme turbulence that can accompany the kind of storm conditions Flight 2501 encountered. A plane that broke apart on impact in violent storm conditions could distribute wreckage widely and drive heavier pieces into deep sediment where sonar penetration is limited. The explanation is plausible. It does not fully account for why the main fuselage specifically, which should be both large and relatively dense, has not been located in any of the subsequent searches. The lake keeps what it takes. The Ice Age hunting grounds. Beneath Lake Huron, at depths that divers with appropriate equipment can reach, there are stone structures that were built by human hands. Rows of stones arranged in lines, low walls designed to channel animals. Hunting blinds constructed to hide hunters from their prey, tool fragments from people who sat in those blinds and waited. The structures date to approximately 9,000 years ago. At that time, the area where they stand was not a lake bed. It was open land, a landscape that human hunters were using to intercept caribou during their seasonal migrations. The land where the hunting structures were built was above the waterline. As the glaciers continued melting over subsequent centuries, the water level in the Great Lakes Basin rose and eventually covered the hunting grounds. The stone rows and blinds are still in the positions where the people who built them placed them. Divers who have visited these structures describe the experience in specific terms. You can stand in full diving gear on the floor of Lake Huron, next to a stone blind that a person built 9,000 years ago to hide from caribou while waiting to hunt. The scale of that temporal connection between the person who placed those stones and the person now standing beside them in cold water where dry land used to be does not have a comfortable frame of reference. The water that turned toxic. On August 2, 2014, the city of Toledo, Ohio issued a water emergency advisory. The language of the advisory was not the standard precautionary language of minor contamination events. It said, "Do not drink the water. Do not boil it. Do not let it touch your skin." More than 400,000 people were affected. The cause was a massive bloom of blue-green algae, technically cyanobacteria, in western Lake Erie. The bloom was producing a toxin called microcystin, which damages the liver. Boiling water that contains microcystin does not destroy the toxin. It concentrates it. The instruction not to boil was not rhetorical caution. It was a specific warning that the standard response to contaminated water would make the situation worse. The source of the bloom was phosphorus runoff. Agricultural fertilizers applied to fields in the Lake Erie watershed wash off those fields when it rains and drain into tributaries that feed the lake. Lawn chemicals from suburban properties contribute the same way. Phosphorus is a nutrient that algae need to grow. When phosphorus concentrations in the lake water rise, algae populations explode. Blooms large enough to see from satellites can cover more than 700 square miles of lake surface. The feedback loop driving these events is getting worse. Warmer water temperatures encourage algae growth. More frequent heavy rainfall events associated with climate change wash more phosphorus off more land in shorter periods. The Toledo crisis was not a one-time event. Algal blooms in western Lake Erie have occurred every year since, varying in size and intensity, but not disappearing. The invisible invaders. In the late 1980s, cargo ships arriving from Europe brought an invisible problem into the Great Lakes. Their ballast tanks carried tiny zebra mussels and quagga mussels from the Caspian Sea region. When the ships released ballast water before loading cargo, the mussels entered the lakes. At first, almost nobody noticed. By the time scientists understood what was happening, the invasion had already spread across the entire Great Lakes system. Today, the number of these mussels is almost impossible to imagine. Scientists estimate there are hundreds of trillions covering rocks, docks, pipes, and huge areas of the lake floor. Each mussel constantly filters water, removing tiny plankton and algae. That may sound harmless, but plankton is the foundation of the Great Lakes food chain. Small fish depend on it to survive, and larger fish depend on those smaller fish. When the plankton disappears, the entire ecosystem begins to change. The strange part is that the water now looks cleaner than it did before. Many people see the clear water and think the lakes are healthier. The opposite is true. The mussels are removing so much microscopic life that the water becomes unusually clear. It is not a sign of a healthy lake. It is a warning that the natural balance has been disrupted. With less plankton available, young fish struggle to find enough food, and some fish populations decline. The clearer water also allows more sunlight to reach the lake bottom. That extra light helps harmful bottom-growing algae spread across the lakes. Some of these algae produce dangerous toxins that can poison wildlife, pets, and even drinking water supplies. What arrived hidden inside cargo ships completely changed one of the world's largest freshwater ecosystems. A creature only a few centimeters long has reshaped the food chain, altered the lake's chemistry, and created problems that scientists are still trying to solve decades later. Forever chemicals. The floor of the Great Lakes is a record of every industrial and agricultural decision made in the watershed over the past 2 centuries. Mercury from industrial processes, PCBs from electrical equipment, dioxins from manufacturing, And more recently, PFAS, the group of synthetic chemicals used in non-stick coatings, waterproof fabrics, firefighting foam, and dozens of other consumer and industrial applications. PFAS are called forever chemicals because they do not break down in the environment or in living tissue. They accumulate in the sediment on lake beds and in the bodies of fish that live in contaminated water. Health advisories limiting how often people should eat fish caught in specific parts of the Great Lakes system have been in place for years. The advisories are not theoretical precautions. They reflect measured contamination levels in fish tissue that exceed the thresholds considered safe for regular human consumption. The future risk is specifically connected to storm intensity. The contaminated sediment on the lake bed is relatively stable under calm conditions. Stronger and more frequent storms, which climate projections consistently predict for the Great Lakes region, disturb bottom sediment and can resuspend material that has been settled for decades. Contamination that has effectively been sequestered in the sediment could be remixed into the water column, exposing the water supply and the fish population to concentrated levels of the same chemicals that were deposited years or decades earlier. What sonar keeps finding under Lake Huron, sonar surveys have found sinkholes hundreds of feet across. The water inside them is low in oxygen and high in sulfur, a chemical combination that is toxic to most life, but that supports specific microbial communities that do not require oxygen. NASA researchers have used these sinkholes as study sites for understanding how life might exist in the oxygen-poor oceans of other planets, where conditions similar to the Huron sinkholes may be present. The same sonar surveys that found the hunting structures and the stone carving have found ancient shorelines, standing tree stumps from forests that were drowned when the lakes rose, and carved riverbeds that were active waterways when the land above them was dry. The Great Lakes Basin is an archaeological record of the landscape that existed before the current lakes filled their basins, and that record is still largely unread. Researchers working on lakebed mapping have noted the uncomfortable comparison between what is known about the surface of the Moon and what is known about the floor of the Great Lakes. The comparison is not rhetorical. The bottom of the Great Lakes has been mapped in portions, with significant gaps and at resolutions that leave large areas poorly characterized. The floor of the lakes that supply drinking water to 40 million people is less well mapped than the surface of another world. The Great Lakes still hold discoveries, dangers, and mysteries that scientists are only beginning to understand. Every new finding changes what we thought we knew. If you enjoyed this video, like, subscribe, and comment for more stories about the world's greatest hidden mysteries.